Hi everyone, this is teammate of Electronic System Design 2 class, and this is presentation 4. And our project is Rukman Ohans, and he joined in this presentation by me, my teammates Matthew, Jason, and Louis. So let me go through the project description. So basically, Rukman Ohans is a smart chess board that moves with the pieces on its own. So it supports virtual opponents and far-off opponents, and we have a chess engine built as well. So all the chess pieces have magnetic pieces and Hall effect sensors. To enable an electromagnetic motion system, which is an CNC head-style based gantry, to move the chess pieces from one square of the chess board to another square. So, and we are manufacturing most of the pieces on our own, and we aim to build a good and a robust chess design.
I'm going to give an update on our progress on the milestones. So milestone 4, our goal was to get everything complete. So get the gantry working, completely operational, get both the power electronics sorted. So from 12 volt, from the wall to 12 volts to the stepper drivers, which are relatively high power, and then getting them working in conjunction with serial commands sent over to the coprocessor, and also the coprocessor to the stepper drivers to the steppers, and getting all that chain working, and then that integrated with the mechanicals. So good news is we got that all done. So all of the gantry components are working together. There's still some optimization to happen, but that can happen as we start to add more pieces. So milestone 5 is obviously going to be putting everything together. So we're going to integrate everything. We've been developing pretty much everything in parallel so far, making sure that they fulfill their various requirements, and then using interface control documents, ICDs, to control the interfaces between the two. And the next 2 weeks are going to be focused on integrating these parts and squashing any bugs as soon as they come up. So lots of group work ahead. And pass it on.
So as we mentioned last time, we have redesigned our PCBs that contain our Hall effect sensors. This is because there were problems with the outputs of the different sensors interfering with each other on the same line. So we have since added a diode to protect that. And so these boards have since arrived. We have all of our parts for them, and we have begun on our assembly of them. So we need to make 16 total. The assembly themselves is pretty simple. We just need to do for each square. So each PCB themselves has 4 squares total. Each one has a sensor, a bypass capacitor, and a diode. We just need to do that for each one. So 64 sensors total. It's going to be a lot of work. We need to then wire all of these together such that they are 2 inches apart. Like each sensor is 2 inches apart, and then we will need to insert these into our board enclosure. And then in addition to this, we have designed and ordered our PCB that is actually going to contain the ESP32. And all of our sensors will connect back to this, and then this board will in turn be connected with the serial connection to the main ESP32.
So let me go over the design progress of the software and the main processing board so far. So ever since milestone 4, what we have achieved is regarding sensing functionality of the main board, we have implemented the main board to get the sensor state of every square from the coprocessor, and we will be establishing communication with the coprocessor via UART. We've also implemented the firmware to detect any changes made in the state of the board. Also, when a move is executed, the coprocessor will transmit some sort of a message to the sensor to the main board that the move is made. The coprocessor board will transmit a simple message saying the move is made. And likewise, the main processor board and the coprocessor board can send and request the states of the board, the current states of the board from each other. And moving on to the G-code libraries, we are planning to use GRBL/ESP32, which is a popular CNC firmware library designed especially for ESP32. So it supports G-code commands, and we believe this library will be best fit to move the CNC gantry system integrated along with the G-code. And we have also designed a main board which will be the main processing board to integrate with the coprocessor boards, and also which will be using a UART. So basically an RX and a TX pin is all we need to like move the gantry. And also for the coprocessor boards, we will be implementing like an enable bin, for example, which is always set high, and maybe when a move is made to detect that, or to drop it low to detect that the move is made, and various other features for the main processor board. So what we will potentially be working on milestone 5 will be integrating everything which we have worked on so far. So which will include the server, the CNC gantry, the main processing board along with the co-processors. So we will be implementing all of this together to make and function as much as possible.
I will now be going over the design progress since our last milestone, and this will be concerning the Python library and the API, as well as the sort of game logic design. So from the last milestone, we have begun to research and write the code for the Lichess API side of the firmware. This side is sort of the side that deals with keeping the status of the board updated on a separate server so that we can keep a record of the board, as well as implement a AI bot that will also interact with the player and make the moves according to the player's selected difficulty. So as such, we will need to continuously update the state of each game every time a move has been declared as finished. And this a bot will essentially take in that move and respond accordingly with some sort of level that we give it. Of course, this bot, due to the API, has some things that we will need to do with creating an account and turning it into a bot account on the Lichess host server. Additionally, we have sort of determined the entire game structure of the API, and we're sort of in the process of implementing the API into the server. So as I've just discussed, we sort of send in a new move and the bot becomes updated, and we send the bot move back to the board in chess notation. And basically the ASP32 will then take that chess notation and move the gantry according to where the pieces need to be moved by the bot. And once that move is finished, the player can now respond and basically repeat over and over until the game is declared over by the player, or the game is updated and we have reached a point where there is checkmate, draw, or stalemate. And then finally, the game will somehow be recorded onto a Lichess host area. So we're sort of still in the process of determining how to correctly store the games, because it appears that the best way to do it would be to have each user log in with their own Lichess account, and the games can be stored there. However, if we don't want to do that, there could be there are possibilities of other ways to store the Lichess the games on the Lichess server.
Going to talk a little bit about the design progress that we've been making with the manufacturing portion. Good news is it's all done. The gantry is complete. We're running into some issues, mainly regarding stiffness. That last item there is in relation to the cross slide. So those two parallel bars that are close together that need to move in tandem alongside along the other two independent axes. And that's having some issue with some stiffness. So when they become out of alignment and they're not in the same line and they go skew across, they're not square to the original ways, then it can basically cam onto the shaft and bind, causing issues for the motors, jamming them up. The motors that we have aren't strong enough to just overcome that. So we need to work on reducing that. Using lubrication, you can see our little oil can up here, has helped a lot. So we just lubed up the slides and it's moving pretty well. One thing that we want to work on is getting rid of some of the noise. We're using kind of low quality drivers and low quality steppers, but there's a lot of motor noise and there's a lot of belt noise. So tuning the belt height would be one way to kind of buy down that noise that we're seeing, which would kind of hurt the effect. One other thing we did was interview a room full of my chess obsessed friends, and they're really into it, right? There's a market for this. They're willing to spend for it as well. One of my friends said, "If make wizard chess, and I'll pay a lot of money for it." So, right, it's a big investment piece. So we're looking for high quality, high polish on the design, with a little bit less concern with regard to BOM cost. One thing that was important to everyone is the kind of like magical aspect of it. So making sure that it appears almost magical in how it operates. So hiding all the components, making sure it's quiet and it moves like magic. Wizard chess was the thing that came up a bunch, like Harry Potter. In terms of functionality, we did talk a lot about how to confirm a move. It seemed as though most people were interested in like a touch move playstyle, where as soon as your hand leaves the piece, the move is confirmed, which makes the software side easy, right? You just have a little counter. So I think that's a good way to move forward. Clocks could run into some latency issues. That was worrying for people who like to play bullet and other quick styles, because as you start to get towards the end of the game, it can be hard to figure out when the clock starts. You probably need a period for the chessboard to actually execute its moves, because it doesn't operate that quickly. So stuff like that is of concern.
Something new to me when working on this project is using Visual Studio Code's GitHub integration, as well as Platform.io's GitHub integration. So in the last week, we made a repository in order to share our firmware with each other, since this is the main focus of what we're trying to get done right now. And so what I did not know before this is that Platform.io folders will be specifically formatted with a gitignore file at the end, in order to basically ensure there are no difficulties coming about from trying to track files in settings folders like .vscode or .pio, because normally that can cause a lot of interference whenever you try and like push your changes to the origin. So just being able to drop the entire project folder into the GitHub and just have it work very nicely is very convenient, and it's made a big difference with us trying to collaborate with each other.
Our team's first question has to do with as we are completely integrating each of the subsystems together, we're sort of wondering, from this presentation, have you have any sort of feedback or suggestions regarding our project or the direction we're taking the project to as we finalize things? This can sort of just be general, or it can be more specific, but we kind of just want to know, as we're sort of putting everything together, if there's any last minute things that we might want to look out for or sort of improve on. And our next question is has to do with the chessboard enclosure. So while all these subsystems have been done, and we're sort of in the process of integrating them with the PCBs and the gantry system and sort of firmware, we still haven't yet actually manufactured the chessboard enclosure. So we have the sort of idea of putting in an acrylic piece for the actual chessboard, but the rest of the enclosure that will be surrounding the gantry and sort of covering everything up hasn't been made yet. And we would just sort of like to know, are there any sort of enclosure designs or recommendations that you might have in mind that you think would be good for our chessboard to have? And this can really be anything from the design to the material that you might suggest we use that might make it easier for us to manufacture, or that you as a user might want to see or experience. And as always, thank you for watching our presentation, and we look forward to hearing your feedback.